Hello everyone. In this video I am going to demonstrate SMPS design with a 220 volts AC input and a 12 volts AC output at 2 ampere. As you can see, this is the setup on a breadboard, and here you can see this is the input section. 220 volts AC is fed to the bridge rectifier, and the output of the bridge rectifier is 220 volts DC fed to this filter capacitor, and the output is finally fed to this circuit. And I am going to explain this circuit, then I will show the demonstration. So now, as you can see here, this is the circuit diagram. As you can see here, this is the heart of the circuit, IC TL494. This is how the circuit is wired. You can see from the pin number 8, the firing pulse of 60, the firing pulses are sent. This is the control point, and from here pin number A is connected to the IGBT here. I am using 25 and 120 IGBT. So here you can see the TL494 is configured to generate a frequency of 65 kHz. I am using 22 picofarad capacitor and 200k resistances in series to get a frequency of 65 kHz. There is no feedback circuit employed here. I am using the TL494 as an oscillator. So there is no closed loop control in this circuit. The output, pin number 8, is fed to the IGBT here, as I have said already. And here you can see the supply voltage is pulled up with a 330 ohms 1 watt resistance here, and a current limiting resistance of 100 ohms 1 watt. Here you can see this is the AC input section. AC is fed here with a line filter followed by a bridge rectifier and a filter capacitor, and from here I am using 347k resistances in parallel to get a 15k equivalent resistance, and this voltage here initially drives the TL494 IC. Finally, when the oscillation starts, you can see this is the transformer, and from here you can see this voltage, this signal is 65 kHz. This voltage is fed to the IGBT here, and the IGBT finally drives this transformer. There is an auxiliary winding in the transformer. You can see here, this is a Schottky rectifier, and it is fed to this point. You can see here it is fed here, and from here you can see it is maintaining a voltage of 12 volts, and this voltage is fed to the TL494 IC. So that means initially when we switch on the power supply, the power is taken from this loop. You can see the control supply is taken from this loop, and later on when the circuit TL494 starts oscillating, this auxiliary winding will feed power to the TL494. You can see the auxiliary winding is connected here, and from here it is feeding power, and the same point is connected here also. So from here the TL494 will be driven. That means initially the power is fed from this network, and after that, once the oscillation starts in the transformer, the auxiliary winding feeds power to the TL494 IC. You can see here, this is the transformer I have used. You can see 25 turns copper wire in the primary, 6 turns each in the secondary with a center tap, and there is a 6 turns auxiliary winding. You can see, and this is the IGBT 25 and 120. So this is how the circuit diagram looks like. I will demonstrate the entire circuit. Let me show the transformer design first. As you can see here, this is the transformer design. You can see I am considering the input voltage as 230 volts DC input voltage. So this is the formula. You can see here I am having a frequency of 65 kHz. I am having a flux density of 1500 Gauss. The core area is 69 millimeter square. You can see, so upon calculating it comes 85 turns. So the primary for 230 volts DC supply is 85 turns, and the secondary winding calculation comes 6 turns. You can see here, you can see the output is designed to be 12 volts into 1.414 root 2 RMS value. It is 16.98 volt. When we are dividing with 230 and multiplying with the number of turns in the primary, the secondary turns comes nearly 6 turns. So this is how the calculation looks like. So now let me switch on the circuit, and we will see the responses. So now I am going to power up the circuit. I have switched on the circuit. it is generating DC 220 volts DC here. You can see here it is generating 220 volts DC, and here you can see 295 volts DC, and here you can see the circuit is generating. Just a minute, let me switch off the light. I am facing some issues here, so I will show you from the far little. You can see 37 volts AC. You can see this is the transformer output. Here you can see this is the transformer output, and here you can see this is the MOSFET. This is the voltage across the primary of the transformer. This is the secondary of the transformer voltage, 37 volts AC, and this is the primary of the transformer. You can see this is how it looks. So here you can see this voltage I am getting 299 volts, and this voltage I am getting 37 volts. This voltage is little high because my transformer design is 230 volts, but you can see here I am feeding 295 volts. So now let us reduce the transformer voltage. Just a minute. I am reducing the transformer voltage. So now here you can see the supply voltage is 230 volts DC. This voltage is fed to the transformer. You can see here the transformer primary is now 198 volts AC, and the output is 25 volts AC. You can see here the output is 25 volts AC. Let's look into the frequency. Let me press the frequency button. You can see the frequency is 63 kilohertz. The duty cycle is 49% or say 50%. You can see, so this is how, see, as per the design, here it is 12, 0, 12. So between these 2 points, I am getting 24 volts AC. You can see, so this is how the circuit works. Thanks a lot. Thanks for watching. Please watch the description link. I will be showing the entire design file in the description link. Thank you so much.